Thank you very much. I think we're going to start now. Good morning, good afternoon. I want to welcome everybody that is here formally now for now at the StatsTalk-Africa on monitoring roads at a large scale in low-income and developing countries doing big data and remote sensing. First of all, I to thank everyone that is joined. But first of all, let me just do a bit of housekeeping. I know that we are all used now with the webinars, but it's important just to again remind everyone that if you do have any technical issues, please do chat, put it in the chat. But also, if you have connection with our colleagues that are managing it, the platform, do send an email very quickly so that we can make sure that you are properly connected and also to be able to participate in the conversation. I also want to just remind ourselves that if you have a question, please, while waiting for the Q&A, you can still put the questions in the chat. But in the meantime, what we're going to do is to allow the presenters, the two presenters, to make their presentations. And then thereafter, we open the discussion, but that does not stop you to put the questions in the chat. And in some instances, we also try and respond to those questions. May I also mention that we are going to record this particular session that is here. So if you want to hear or repeat what has been said, please, you're welcome to go back to what has been recorded. So as part of just a continuation of this program, let me recognize everyone that is here, in particular our two presenters, our esteemed distinguished guests that have joined us from different places. I know others will still be joining us. I just want to wish ourselves a good morning, a good afternoon, depending on where you are. My name is Oliver Chinganya. In case you don't know me, I'm Oliver Chinganya. I am the director of the Africa Center of Statistics, but also chief statistician for United Nations Economic Commission for Africa. So today I will lead this session, and therefore I want to, again, like I said, welcome you to the 15th StatsTalk-Africa webinar series. As most of you already know, we have been running this webinar series since April last year, which are really aiming at providing space for dialogue regarding data, statistics, and innovative tools with data experts and users. The sessions aim to promote better understanding of statistical concepts and alternative data sources and tools. They are positioned as a knowledge-sharing platform, promoting dialogue among data experts and users, as you'll hear today from our two experts. The forum, first of all, aspires to unpack very complex statistical concepts and terms for better information utilization. The StatsTalk-Africa session really invites experts, first of all, from ECA, but also of expanding our invitation to member states, including our development partners in the academia and others that are really interested or associated in data and statistical elements. So today, our focus is going to be on monitoring roads at a large scale in low-income and developing countries using big data and remote sensing. As we unpack these kinds of topics, I think what we're also going to hear is the practical applications, which I believe are vital in improving the way we measure things to make sure that we do the right thing. So maybe a little bit of background to put things in context. I think we know that today is digital age. Really, the demand for data and evidence has never been greater across all sectors of society. International initiatives like the Sustainable Development Goals and Agenda 2063 have emphasized the critical role of data and indicators in shaping policy frameworks. National and international statistical systems are under increasing pressure to provide correct data for planning, decision-making, and policy formulation, including catering for the needs of government agencies, development partners, researchers, academia, as well as the general public with whom we serve. So specifically, focusing on the infrastructure domain, the need for data and monitoring tools has become much more important. And governments, therefore, worldwide allocate a significant portion of their GDP towards maintaining roads and ensuring road safety and connectivity. Despite the substantial investment, global road networks face challenges such as poor maintenance, underfunding, and vulnerability to climate change, especially in low-income and developing countries. A key issue to note here is the contribute to these challenges is the lack of comprehensive and up-to-date data on road infrastructure. Governments struggle to collect essential data seamlessly and cost-effectively, hindering their ability to prioritize tasks and plan for their future effectively. However, advancement in remote sensing and big data offer promising solutions to map networks, assess pavements, conditions, and optimize maintenance work, as you are going to hear today. So in today's session, we'll develop a little bit more on practical examples of leveraging satellite imagery, artificial intelligence, and modern data management system to address these road infrastructure challenges. And therefore, really, I want us to, join in looking at these innovatives that we're going to discuss this morning. And therefore, we will have two presentations. One of them is going to be looking at innovative technology and management of regional transport corridors and application of satellite imagery and artificial intelligence. Then after that, we'll have another one that will be focusing on monitoring roads at a larger scale in low income and developing countries using big data and remote sensing. And to do that, we're going to have the first session itself that I mentioned. We will have Roberto Croce, who is going to share a little bit of some insights on the African Regional Transport Corridor management system to demonstrate how satellite imagery and artificial intelligence are used to assess critical roles for optimizing the benefits of the Africa Continental Free Trade Area. Just for you to know Mr. Croce a little bit more, he has a master's degree in electronic engineering with specialization in computer science and automation, and graduated from Summa Cum Laude from Sapienza University of Rome. He's currently a technologist at the Department of Civil Building and Environmental Engineering at Spezia, University of Rome, and currently also holding the position of coordinator for information technology team at the Research Center of Transport and Logistics at the same university. And he is also a chief technology officer and senior partner at Sapienza University, a startup. So he has over 28 years of experience, as you already will be hearing about him on many things, which include data management, specializing in geographic information system, system administration and management for client and server, as well as the web application design and development, and artificial intelligence. So we look forward really to hear a little bit more on these challenges that he's going to present to us. So Roberta, without further ado, I would like to give you some moment to give us our presentation. So over to you, Roberta, for the next 20 minutes.
Yes, thank you for the introduction, for the summary of my biography. Thank you to everyone. I'm very honored to participate to this workshop today with the UNECA. And I'm going to share my screen for the presentation. Just a moment. Okay. This one. Okay. I hope you can see my screen.
Yes, we can. Just push yes, please. We can see it in full presentation. Okay. Please go ahead. Yeah, thank you.
Okay. So as was presented, I'm working for Sapienza University of Rome, and we are working in a project for investigate and for application of the innovative technology and management of regional transport corridors in Africa. We are applying this methodology in the Central East area of Africa to three corridors: the Northern Corridor, the Central Corridor, and the Lapsat Corridor. So I will show you which is our work, which is our project, the background of this project, the objective of the project, the approach, the action plan to obtain the objectives, and the way forward. So what we are expecting that in the future we can do with this methodology. The background that we have found in finding the information and retrieving information about the transport infrastructure in Africa is a very issue that we met. So there was a problem in obtaining data from the member states of the corridors that crossing the states. We encountered some difficulties in assessing the state of art of the implementation of the corridors. And also we found the difficulties in assessing the state of the infrastructure that is existing at the moment. So which was our approach? Our approach is to use big data and also satellite imagery and the technology that is now available also for the artificial intelligence to get this information using big data in regional context and satellite imagery together with artificial intelligence. We base our experience on some pilot project that already have been done in Africa for this, and also we as a Sapienza University, we have done a pilot study before of this project concerning the use of satellite imagery in this country. And also we have asked some technical assistance from the stakeholders of the corridor organization to get also the validation of our data, of our approach. What we would obtain, which are our objective, is to strengthen the capacity of the regional organization to manage the cross-border transport infrastructure that are represented by these three corridors. And to obtain this objective, we use, as I said before, innovative technology to manage the infrastructure assets of the organization, and to monitor and evaluate the corridors, the regional transport corridors, without asking a lot of requirements and information from the member states. And also the possibility to build the capacity to give to the Economic Commission of Africa and to the corridor organization, to the member states, to use this methodology, this satellite imagery and artificial intelligence, to monitoring the transport infrastructure and to management the asset of the transport infrastructure. So our approach is divided in 4 steps. The first step was the capacity to reconstruct very precise the routes of the African development corridors, because we didn't find a very precise, in most cases, a very precise reconstruction of the network, of the roads, of the railways, and of the pipelines trajectories. So we have done, first of all, this kind of work, and we have reconstructed all the trajectories of the roads, first of all. And then how to assess the state of the infrastructure. Particularly, our work is focused on the road infrastructure for the corridors. So we would like to know which is the progress in the project's implementation. So if the roads are finished, are completed, or are still in construction. And we try to get this information using satellite imagery as the first sources. So our object was to see for the various sections of the road corridor, if they were under construction or completed, the type of road surface, if it is paved or unpaved, the width of the road, the number of lanes, the state of the surface, and then also the presence of some other infrastructure like tunnels, bridge, and viaducts, only using satellite imagery. So the second step was to localize the 3 corridors on the map. We have rebuilt the trajectory of the 3 corridors, the northern corridors, that is the violet one, the central corridors, the orange one, and the lapsed corridor, that is the red one. How we have applied this new technology aspect for example, for defining the road surface. In this case, you can see a multispectral satellite high definition imagery that is a part of the central corridor that is in Burundi. You can see the first image on the top. It is the reconstruction of the trajectory of the part of the road that is in blue. Then you can see the RGB image at the middle. You can see that in this case we have a transition from an asphalt surface that you can see on the right to a dirt surface, the dirt road that is on the left, that is earth road. And you can see that we can see this different looking at the satellite high definition image, RGB image, but also looking at this multispectral image in which you can see the red part of the road, that is the asphalt part, and the other part of the road that is some gradient of blue and green colors. That means that in this part we don't have asphalt, we have earth instead, or sand. So you can see that it is possible to discriminate between paved and unpaved, and we can also train a neural network just to understand, looking at this image, examining this image, if the road is paved or unpaved, also which is the material in which it is the paved implementation. Another thing that we can notice is the presence of bridge. For example, in this case, we have a river that pass under this road, this part of the road, and we can isolate a bridge. You can see that we can see the shadow of the bridge on the water, and also you can see the columns at the entry and the exit of the bridge. So also you can identify other infrastructure, also architectural infrastructure, that are present in the bridge. You can do this using the RGB image or the multispectral image. And you can also, in this case, train a neural network using machine learning or deep learning to identify this situation. This other situation is the situation in which we would like, for example, see how many lanes are present. In this case, we have 2 lanes. And also how is delimited the marking, the horizontal marking delimiting the lanes. You can see the line that delimited the lanes. At the center of the road, using only satellite imagery, you can see that is a continuous line, or a dashed line for the central part. And you can also see that at the board side part of the road, you can have, in this case, the dashed lines of both sides of the road. And you can do this using together RGB images and multispectral RGB imagery. And of course, also in this case, you can train a neural network for machine learning or deep learning that can automatically recognize this kind of situations. The third step is what we have built is an infrastructure, a framework that can handle this information. So first of all, the framework is built upon a geospatial database that can load all the information, geometric and geographic characteristic of this road section of the 3 corridors. And we have used the open source software tools to build our framework. The database is a PostgreSQL database with PostGIS extension for geospatial application. OpenStreetMap as the base map information. Also, we have used some tools like PG Routing and Google OR tools for routing problems that we applied to our problems. We have used QGIS as open source geographic information system as a desktop GIS. And then we have used also GeoServer platform for publishing geospatial data and interactive mapping to the application on the web. The final result that we would like to achieve is to give to stakeholders of the corridors and also administration a tool, software tool that is built upon this architecture, in which you can put some vectorial file, a geographic file, shape, OKML, KMZ, or GeoJSON, GeoPackage. You can prepare data using QGIS. You can publish data with the GeoServer using also GeoWeb Cache to cache the images, and to serve this information to the web application. You, of course, have the PostGIS database as a database to all the information, geographic or not geographic, also socioeconomic information. And on the left, you can see that you can have some tools from a client side in JavaScript, in which you can use for rendering the images into your browser or your dashboard. So leaflet, Google Maps, OpenStreetMap, GeoExt. So the approach, our final approach is building this web application. Now we have built just a part of this application. We are still finish our development, in which we are going to publish and share the geospatial data for interactive mapping queries. So we would like to build an interactive web application based on map, in which you can see the corridors. You can add the information, not only geographic or geospatial information, but even socioeconomic information concerning the people or the area that are relevant around the corridors. We are going also to give private access to some information on this platform concerning the stakeholders for the corridors of the administration. So people with a specific role can access this data and can have only some function enabled, like viewing or editing, add or modifying some information, or querying the map with the possibility to use also filtering filtering tools. Once that the people will log, they can zoom and pan on the map. They can choose the corridor interest in the interactive map. They can also, by themselves, load the extra layer into the map with the socioeconomic information to compare in different scenarios on the interactive map. And they also can query some data on the road infrastructure on the map, clicking on the element of the map, for example. In this case, we have the Lapset corridor represented in this map. If you click on an element on the road, you can have a pop-up with the information about, for example, the project of Lapset, the type of infrastructure is a road, the status of the project is in progress, the country that are interested by the project, Kenya and Ethiopia, and so the description, the total amount of dollars, the distance, the total distance of the road, and so on. Also the key beneficiaries of the project, and so on. All the information of interest that we can collect. And also you can zoom on the map, on the corridor, like in this case. And at the end of the maximum level of zooming, you can also click, and if it is present, the function, you can see the Google Street View button, and so you can have a view of the infrastructure that is at the road level with a very, very high definition resolution. But of course, this is not available for all the part of the corridors in Africa, but only for the part that are inside the center of the cities, or part that are useful, that are important for economic or commercial aspect. This is an example we have done in a Lapset corridor near Loruk, in the road before Naruku Saigon Road. Of course, we would like to improve and to enhance the quality of road infrastructure assessment using imagery and artificial intelligence. Of course, we can use high definition satellite imagery. We can achieve 30 centimeters or 50 centimeters of resolution for the high definition, and 1 meter and a half for low resolution image from satellite. But if we use, for example, drone or aerial movies image, we can have very high resolution, and also we can have very high resolution if we collect data using a dash cam mounted in a movie car, for example. Of course, in this case, we can improve using artificial intelligence the automatic detection of all the elements present in the infrastructure, even for example, traffic signals, if are present, not only the horizontal one, but also the vertical one. We can train some neural networks to automatically recognize the traffic signs or the element in the road infrastructure. At the end of this work, what we would like to do to have a validation of our work is to send the information to the expert validation. And so after the final update based on the expert validation, we can publish the data of the corridor in the web application. Of course, for the future, we would like to share the web platform with all the stakeholders involved in the project. And we would like to extend the pilot project of the web portal also to other African development corridors. And of course, we would like also allowing people that can use the platform to add other information by their own new data layer to be visualized in the map. And also, we would like to extend the analysis to other aspects. And first of all, we would like to implement artificial intelligence tools for predictive analysis for commercial trade flow along these corridors routes. So I finish. I hope to not have used too much time, and I hope that I have explained in a good way what we are doing, what is our work, and I thank you for your attention.
No, thank you very much, Roberto. I think you did explain it. I think very interesting presentation, and we're really looking forward to the exciting news, in particularly the idea of extending the project to other African development corridors. I think that will make really bring a lot of value and also use of these initiatives. I want to believe that even the authorized operators will also be interested, in this kind of information to add on to the way they trade, for instance, across borders, and to do further analysis even before they embark on their own kind of trade. So I think it's very useful to colleagues. As I said, bank your questions or put them in the chat, and some of them Roberta may begin to answer, and then some of it will at the end when we open up the Q&A, you'll be able to ask questions. So we'll move straight to the next presentation, which will be made by Diamine Bey, who will discuss the cooperative efforts of the International Monetary Fund and the World Bank in developing a new platform designed to help countries monitor the size and quality of the roadmap network in real time at a low cost. And also the using of these inputs to measure investment gaps, sequence road maintenance work, or simulate the resilience of road networks to create shocks to better pilot investment. He will also explain how the tool can be leveraged for other tasks, such as generating road task statistics at a micro level, and in computing SDGs, for instance, the Road Access Index, or assessing returns on the future road renovation or construction using country case studies. So Diamine is a senior economist at the IMF Research Department, and also a consultant at Altia, a leader in computer vision, spatial image analysis, and infrastructure monitoring. He's an applied macroeconomist with a strong research background in applied econometrics and big data analysis. So we have the right person to tell us a little bit more about these things. He is currently leading a big data and public good initiative at Altia, which aims to leverage innovative techniques, in particular remote sensing and Earth observation, to address the macro questions using mainly the free or open source visual and non-visual data. In that context, he will also, he designs tools, so to speak, that help governments and international organizations monitor the size and code and condition of critical infrastructure, such as roads, rail, grids, and et cetera, to optimize maintenance tasks, pilot investment plans, or improve the resiliency of infrastructure network to climate change. Diamine also holds a PhD in action economics and from EUI and Masters in Economics and Finance from the Sciences for Paris and the ESSEC Business School. So without further ado, let me invite Diamine to take us through in the next 35 or so minutes. Again, please do write your questions on the chat so that we can be able to respond and maybe even interact with him at the end of it. So over to you, Gamin.
Thank you very much, Oliver, and thanks you, Roberto, for the presentation as well. Let me share my screen. First, whoopa. Okay, is it fine? Oliver, can you see the screen?
Yeah, I can see the, yeah, excellent.
Very good. Let me just put this here. Okay, so as you mentioned, the presentation is going to be about monitoring roads at a large scale in low-income countries using big data and remote sensing. So just a bit of background. On the project. It's part of a global research project on a large-scale mapping and monitoring of critical infrastructure using, again, big data and remote sensing. I will focus on roads, but we will probably do other things also related to rail and grid, but this will be the topic of another presentation. This is a team from IMF, World Bank, and Altea. So World Bank, all of the pilots I will and applications I will present have been done with the World Bank so far. And Altea, just to give you a sense, is a deep tech company headquartered in Toulouse, France, which is the heart of the geospatial valley in France. We have 100 people, of which 50 engineers that are specialized in AI, computer vision, and geospatial data analysis. And what they do is they're specialized in visual imagery, captured by any source, satellite, drone, or sensors, and big data to monitor, operate, and optimize what you define as large and critical infrastructure. So here on the right, you have images. Their specialty, originally was maintenance of grids, like vegetation management or preventive maintenance, using high-resolution satellite imagery or LiDAR. Now, why did I set up this big data initiative, and the output I will present today and why do you need to partner with people like Altea, I believe, is that the first is to overcome technological barriers. So very quickly, when you talk about large infrastructure, you need to manage a lot of data and use techniques at the frontier. And very quickly, you run into the trouble that usually the institutions, even though they have like the IMF or the World Bank, have their own teams, it's become just a different scale in terms of what you need to ingest, clean, and assess and analyze in terms of data, especially with visual imagery. The second is that these kind of firms deal with any kind of data captured from any source and with no limits on the scale. And very quickly, when you do road analysis, you realize that you need a lot of data, not just visual data, but you're going to go catch traffic data, weather data, topographic data. And so you need to be able to ingest this very efficiently. And this is what these guys do. So that's why I teamed up with them. And my objective and the objective of the program is to use the technologies at the frontier that they typically developed for private operators, very large operators, like General Electric, for public policy, but using open data. Again, the objective is not to have a 10 million budget to do something amazing with high resolution imagery, because that I know that some people can do it, but the objective is to use mostly open data so that it's the cost is brought down by a lot. Okay, so everything we do in the context of this project, we do through a platform, and that we use the Altea platform. So there's a dedicated portion of the platform for all the open data projects. I'm mentioning it because it's a web-based tool, and it's a platform. As I said, it's a platform, and it's very efficient and useful for several things. The first is that using this web-based platform, you can collect and visualize road networks and their key features. So we're going to create a digital twin of the road networks and extract some key features. And then it's going to be very easy to navigate the network. This means that it also navigates without training. So one of the things that we wanted to design was a portal where you don't need specific skills like GIS. You don't need to be an expert in GIS to be to use the results of the analysis. The second is that it's very easy when it's something where it's very easy to revisit and track progress over time, potentially in line with the change in the ground, because countries take steps to improve their road infrastructure or their like large development programs. So you need that whenever it's not just a one shot. You need to, when you revisit the imagery or you have changes on the ground, they're reflected directly in the platform. The fourth is that you add new layers in analytics very easily. So I will show you, there is not just creating a digital network and assess the quality of the pavement, but for instance, we develop tools to monitor the effect of climate shocks. Well, then it's very easy to add this piece of analytics and then deploy it in your road network. And the last point is it's very easy also to aggregate up and create macro statistics. Sometimes you just need very simple statistics about your road network. Well, this through the platform you can do very easily. So just a bit of context, I'll be quick because I don't think I need to convince you that roads are a key part of the infrastructure network. But that the problem is that to maintain an optimal network, it requires constant supervision and monitoring. So you need to plan maintenance work, you estimate its cost, you need to prioritize tasks, and you also need to plan future adjustment to make sure the network is resilient to climate change. But the problem we face is that the ground-based monitoring technologies that we have currently are very expensive and usually outdated, especially in low-income countries. So there is no really way to collect data about road networks at a low cost. And even if you had that data, usually you have a very limited access to road asset management systems. So the problem is that it's hard to know the exact size, location, and quality of the network, which leads to a global underinvestment in roads, even in advanced countries. So there is an underfunding of maintenance tasks and the duration of roads globally. It's not just in low-income countries, it's pretty much everywhere. And there's a very passive attitude vis-a-vis climate shocks. So what we wanted to do is fix that problem using innovative techniques, a bit like in what Roberto was presenting. So one is to give a powerful tool to monitor and analyze roads using big data and remote sensing. And this means two things. We didn't want to reinvent the wheel, just basic things, but two big things. One is give authorities, country authorities or country teams, the ability to very easily map and measure the size and quality of roads at a large scale and in quasi real time. By quasi, I mean using the last vintage of satellite imagery. So it's like very recent. This gives you an up-to-date digital twin of your network. And the second is then have built-in applications for the most basic tasks that we identified. The first is to analyze and aggregate. So you want to measure key attributes of the road network, the length, the quality, and produce macro statistics. The second is to help maintain. So by giving you a sense of the quality of the road network, you can better prioritize and sequence maintenance activities or investments. The third is have plugins that simulate climate shocks, such as floods or extreme temperatures, to pinpoint the most vulnerable parts of the network. And the fourth is improve road safety. So identify accident-prone areas using visual imagery and traffic information. So all this we need, this is the objective. Now the constraints. First, it needs to be very affordable. So it would rival with ground-based technologies, but it's produced at a fraction of the cost and time, meaning really, really low budget compared to what would be the counterfactual. The second is it needs to be replicable. So this is a methodology that you want to apply pretty much anywhere and at any time, across countries and time. So you need to be you must be able to revisit and to apply to another country. And the third is the simplicity in terms of the output. It needs to be easy to use and interact with, either on the Altea platform that we set up or with any standard GIS platform, in fact. So you need to adapt to the local needs of the authorities. And the solution we find is you can combine, that's the point of the talk, is to say that you can go very, very far in terms of reaching these objectives under those constraints using a combination of open source big data, affordable satellite imagery, meaning pretty much free, and artificial intelligence. So why now? Again, I think it's pretty clear. There are urgent needs. We have a lot of climate shocks, floods in particular. We need to size investment gaps and pilot investment programs. The budgets are shrinking pretty much everywhere in terms of road maintenance, including in advanced economies. So you need to make the most of what you have. There is also a green agenda. Obviously, it's much better to these new techniques help you to minimize and optimize the use of physical resources, and obviously it's better to maintain and adapt. It's much cheaper rather than wait for shocks and rebuild entirely. And then, of course, once you have these tools, there are a lot of positive spillovers that go far beyond road maintenance. One is it helps official statistics and national accounts. It can be also a critical input for other indicators like the Rural Access Index. I'll come back to it, and for academic research. Okay, so I will be very quick. I mean, I'll give you the intuition of the technical solution. It's not too technical, but it's close to what Roberto was sharing. So there are three fundamental challenges when you want to do what we said we would do. The first is that you need first to know what roads are. Okay, so you need what's the best way to map roads at a large scale. The second is, can we capture accurately the features we need using remote sensing? So meaning, is it possible to really extract meaningful information from the Earth observation? And the third is, can we deploy all these techniques at a large scale in a cost-effective way? And the first two questions are technical, meaning if you had all the money in the world, still, there is a question as to whether it's going to work or not. The third is, well, there is not, you don't have all the money in the world, so you need to be cost-effective. And the solution is going to be a mix of open source data, low-resolution satellite imagery, topographic and weather data, and traffic data. So now exactly what this means, I'll go in the next slide. So actually, the solution works in 3 steps. The first is that we're going to use open source geodata to build a digital road network for the entire country at a very granular scale. We're going to call the digital network. So you have like a digital twin of your road network. Once you have that, then we're going to enrich the network with visual and auxiliary data to derive its key features. And it's going to be, we're going to have 3 sources. The first source is going to be low resolution satellite imagery, which is optical imagery, a bit like the images that Roberto was showing you, which is going to help us pin down whether the road is paved or unpaved. The second is going to be radar, SAR, synthetic aperture radar imagery, which is going to help us derive the condition of the pavement, whether it's in very poor condition or in very bad one, very good one, sorry. And the last thing is topographic data. So this is going to relate to the elevation, the gradient of the road, and this is going to be very useful when we design the effect of climate shocks. Once we have that, we have what we call an enriched digital network, meaning a network with key attributes. And once you have that, we're going to move to step 3, which is you can build on this to derive other byproducts. And the first is what we call the climate shocks. So, simulations of climate shocks, like I will present floods today, and give you a very granular vulnerability index at the road level. And the second is we're going to add traffic information to have safety index. So there's a big literature about whether we can identify the portions that are more dangerous, and this is what we're going to do. So this is just the first step. I will give you just snapshots. And basically, this is the result of what we do when we create the very first step, which is the aggregation, what we call the conflation, to create a digital twin of the road network. So what are we doing? Finding roads on images is actually pretty costly. So actually, we leverage another possibility, which is that we conflate the different sources, open data that are out there already, to create a digital road network at the country level. This is an example of the country level network that we produce in Honduras. On the left, you have the whole network at the country level, and on the right, you have just an example of Tegucigalpa after processing. And what we do is we conflate Microsoft data, OSM, and metamaps. By pooling these 3 sources, we realize that you have an extremely good coverage of any country, any road network at the country level that is also very accurate in the countryside. Because if you only use OSM is the OpenStreetMap, It's very good when it's in cities or where people are reporting because it's a crowdsourced based, but it's not as good in the countryside. And so using Meta and Microsoft Maps, you get a very clean network pretty much at the country level, including the countryside. So this is the first step that we apply in any country where we go, so that we have a digital model, and authorities and teams obviously have access to that, to those maps. The second is once you have the path, so obviously when you're asked to say, process, create the digital network and assess pavement condition in Peru, which is 500,000 kilometers of roads, you have to be very parsimonious in the way you download the satellite imagery. That's going to help you pin down whether the roads are paved or unpaved and the quality of the pavement. And so when we download optical and SAR imagery, we need to do it along the path that is created by the conflation routine, so that you only use what you really need, not the rest. Otherwise, it becomes intractable. So again, optical imagery is going to give us whether it's paved or unpaved, and the SAR is going to tell us about the prediction. Here you have what we do. So for every portion of the road, we're going to use, first, we're going to derive a pavement index, which is binary, whether it's paved or unpaved. And we use what we call optical imagery. Roberto talked about it. You see that the signature on these images is very different between paved roads or dirt roads or unpaved roads. And that's why we have a very good prediction when we train machine learning algorithm to predict using the imagery whether the road is paved or unpaved. Then we go for roughness index. Once you know whether the road is paved or unpaved, we use the SAR imagery to create three classes: good, fair, and poor in terms of the pavement quality. We realize that it is kind of the maximum you can achieve if you only rely on open source, meaning free SAR imagery. So again, if you increase the resolution, you can do better, but the cost is also imploding. So here, this is what you get. We realize that technically speaking, you get around 80% prediction accuracy using a 10-meter resolution in the satellite imagery. And this is what a SAR imagery looks like over Mexico City. And obviously, we've been doing this for like now, I don't know, 6, 7, 8 countries. We'll end up with probably 10 or 15 by the end of this year, but the prediction accuracy improves with every country. The third thing that we do is then we move to topographic analysis and weather-related analysis. So what we do then is, once you have the network, it's enriched, you can ingest new things. One is elevation, gradient, and terrain data. The second is weather and climate-related data. So you add pluviometry patterns, temperatures, river maps, flood maps, so you have a sense of where water hits when it comes to your country. And then using that, you can extract key practicability features such as slope, expected rainfall, or the presence of stagnant water potentially, which is called a TWI, topographic wetness index. I'll come back to it in a second. You can also detect the presence of a bridge by using on the OSM. You can do it, what Roberto was saying with the images, but even simpler, you can use the OSM attributes to detect a bridge. And then you can derive what we call a resilience or practicability index for each road section based on all this information. And the last thing we do, which is a pilot we're doing now, is traffic and road safety. So what we do is, on the same network, you're going to ingest open traffic data to understand traffic patterns and intensity. And using the same imagery, you're going to extract key safety features. So road geometries, curvature, average speed, and detect roadside attributes such as obstacle and vegetation. And this allows you to derive a safety index for each road section based on all this information. Now, note that part of this relies on higher resolution imagery. This is something we're doing in the context of in Mexico, for instance, and it's usually used in for highways or where people actually drive fast. And so the budget is not imploding simply because the portions where you apply this kind of technologies is much smaller. Okay, so these are the 4 kind of things we do. Now I'm going to present the case studies. So the first thing that that we did was apply, it was an step 1 and 2. So creation of a digital network, plus assessing the pavement, whether the presence of pavement and the quality of the pavement at a large scale in Peru and Mexico. So I'm just showing you what happens in Peru. So what you will have is this, again, this network. You have this in a platform, and you can see where the roads are paved or unpaved at a large scale. Obviously, here I'm just taking snapshots because otherwise it's too big. And what happens is, at the end of the day, what do you get? Well, you get 50,000 kilometers, 500,000 kilometers of road that are mapped and assessed that you can navigate in the platform. So this is just an example of, it's an extract from the platform. You click on a section and you get all the attributes on the right. And it's going to tell you, there's a tag for the road, what's its condition, the length, etc., the properties of the road section. And obviously you can use it. So what we have is, at that point, we had delivered this, and the team used it to generate key statistics, such as the rural access index, or use it to plan or budget redevelopment. The second thing was, so once we had created this, the first project, then people in Tunisia asked us, okay, what can you do with this platform? And we said, okay, what we could do is simulate climate shocks and particular floods at the time. So what you see is the result of an analysis I will present in the next slide, but it's just to give you a sense of the objective was to prepare an index at a very granular level of exposure and resilience to climate shocks, to floods. And this is the result of a workflow that looks like this. So I'm going to start from the right here. The project was about road resilience to pluvial flooding. And this is the result that you saw on the map before. And what you see is actually the results of 3 inputs. For each road segment, you need to assess 3 things. One is the criticality of the segment. The second is the vulnerability of the segment. And the third is the exposure of the segment to flood. And the further left you go, the more you see about what feeds into each of these indicators. So to assess whether a road is critical, well, we use what we call the road category. Is it a primary road or a tertiary road? And we use what we call land use and cover and traffic. So if it's bottom line is, if it's a tertiary road somewhere in the forest and there's very low traffic, it's not as critical as a primary road in a very built up area with a lot of traffic. That's obvious, but this is something you need to measure. The second one is what we call vulnerability, which is the ability to withstand the presence of a flood. And this is the condition, it's based on the pavement condition. And in the context of Tunisia, it was also the presence of sand on the road, which we also detected using Sentinel data. Sentinel is the constellation that we use of satellites. And then you have the extreme flood hazard that come from 2 things. One are pluviometric data or flood hazard maps that are open source, so that we have a geographic vision of where the floods are likely to hit. And then we also have the topographic wetness index maps, which tells you about topographic wetness, which is the ability or the possibility that there is ground or stagnant water that accumulates in a certain portion of the road based on its geometry and gradient, topography in a sense. And so this is what generates this kind of maps. Obviously, it's this is what we design in the context of Tunisia. Nothing prevents us to do something else. But what we wanted to have is that a road is resilient. Well, if it's critical, vulnerable, and is subject to a lot of flood hazards. So of course, it needs to be at the intersection of those 3 to flash in red. If it's a very critical road, very vulnerable, and that is subject to a lot of shocks, then you're in trouble. But if not, you flash green. So that's what we developed, same platform. And then you have what we called extensions and byproducts, what I call. So based on all this, you can then do other things. that we're currently working on. I'm going to use extracts from, I'll show you examples mostly in Latin America, because we're developing many more projects in Africa, but they're really in negotiations, so I'm not really allowed to show pictures, but the point is to show what it would look like anywhere. So one is the computation of the rural access index. This is what we're doing for Honduras, for instance. It's very easy to tweak the methodology to compute a rural access index, potentially at a large scale. We know that it's pretty hard to generate the statistic accurately, although it's probably the most significant SDG. But with this platform, then you're just one step away from creating those. The only thing that you need or to add is ingest population layers, which are open source anyway, and urban, rural, not oral, rural areas delimitations. These are also open source. Once you do that, then you can easily define a criteria for what is an all-season road using attributes that you have in the platform. So of course, I guess you know, but the rural access index is the percentage of people living within 2 kilometers of an all-season road. And what we decided with the team in Honduras is to define it using all the attributes in the platform. So whether it's paved or unpaved, and then say, well, we're going to decide that a road is, it's possible to use it all season. If it's paved, then it has to be a TWI above 5, see very low rainfall, and SRTM, meaning the gradient, is below 25 degrees. And if it's unpaved, then it's different cutoff. And if there is a bridge, then it also moves the needle on whether it's you can practice it all years, all season or not. It's just an example. Again, the idea is that if you have a road that see almost no water, even if there is water, it's just very easy to use because the gradient is low or there's a bridge, then it's all season. If not, then it becomes not all season. And this is, I think, very useful because compared to what is done, you have a lot of initiatives to create this rural access index using big data. But I think the main advantages are that one is the better network coverage in rural areas, especially compared to GRIP, which is an alternative to measure to know where roads are, and it's up to date. So you have really the latest vintage of your digital twin. You have a proper road condition analysis because obviously the quality of the pavement plays a huge role in knowing whether the road is going to be passable or not. And this, to my knowledge, processing this satellite imagery to have this pavement condition at an extremely large scale, we are the first to do, but again, I'm not 100% sure, but to my knowledge. And then also you have this climatic and topographic analysis that you can fit to define better what is an all-season road. And the last slide, I think, okay, last application, not last slide, but is what we call connectivity analysis. So here I show you example of what was done in Peru, but we're, for instance, trying to devise this in Congo and Burundi for the bank these days. What you can do is also in the same platform, you locate key existing infrastructure, production and distribution hubs, health centers, school, whatever, future investment projects in the region, anything you find important to measure the potential, economic or social, of any region. And then you can locate, once you put this on top of the network and its quality, well, you can locate the itineraries to each of these potential regions. How many roads, in what shape they are there alternatives, are they used a lot or not, and so on. And what country teams do at the bank with this is derive a granular, what we call economic potential index or a connectivity index. Connectivity, economic potential is going to be more about locating where the key attributes are. However you define them, it's going to be, let's say, agricultural production centers, where connectivity is going to be an assessment of how well this area is connected or how much of a gap there is. And in particular, you can identify the zones with greater development potential meaning where investments in transport infrastructure could have a higher rate of return. So this is the last slide. So I gave you an overview of all the applications we have done and are currently doing as we speak. Again, in the same platform. We have many replications and extensions. Replications sometimes, so country teams come and they just want at the country level, maybe just one block, just the pavement condition, maybe pavement condition plus a climate, and so on. It's a mix. And there are also extensions that are ongoing, sometimes with small twists. I don't know, for let's say climate shocks, for instance, you have islands like Dominican Republic. We're working on it now, and they want to know not so much the pluvial or the flood maps coming from rivers, but it's going to be about hurricane season. So we adapt a bit the methodology to that. We have quite a few, I think we're going to end towards 10 or 15 countries assessed, including very large ones. Again, in Latin America, we started historically in Latin America with all these pilots, so we have more applications there, but Africa more and more. We have processed, I think, Argentina, Honduras, Peru, Mexico. So, again, very large countries. And it's used by country teams or authorities directly or indirectly. So they can have either access to the platform and they navigate the results, or they prefer to download the attributes and all the results into their own platform and then do the analysis themselves. That's up to them. So at that point, what we managed to do is finance all these pilots and these building blocks, technology building blocks in isolation, kind of, thanks to the World Bank. And country teams only pay the marginal cost of replications, which is pretty low. But the next ideal step for us, I think for the initiative as a whole, would be to create a one-stop shop at the continent level, because every time we add a new, first of all, it's more complicated for us to deal with a lot of country teams at the same time, but also it's not very efficient in terms of either price or time allocation, because you need to redo, if people said, oh, I like the climate shocks analysis, now I would like the road safety, then we have to do another set of analysis and contracts and everything. So moving to a road portal, like say at the continent level, would push the marginal costs much lower again. It would serve as a single source of data and truth about roads with a consistent methodology across countries. You would have automatic updates for all countries every year of both inputs and outputs. Obviously, you don't need to do it every year, but revisiting is much easier in the same environment, and ingesting the same, again, you can build pipelines that are there forever. And then obviously you have new analytics that are developed for country X, but you have positive spillovers for all countries that are in the platform. So when we start developing, for instance, the road safety, well, then, instead of having every country ask us individually, can I have the road safety analysis? Well, it would be pushed automatically on the platform. So, and of course, you can use it as a base for other work or indicators that you want to develop on your own, potentially on the platform. It's very important to know that I work with Altea, and the platform is maintained by Altea, but there is nothing proprietary about the platform itself. It's standard format. You can run your own algorithm on it if you need. So, it's very open, and you can use it for other type of work. And that's it for me. Let me stop sharing. I hope I was clear and I didn't speak too fast.
No, Diamini, that was an excellent presentation again. And so many things I was thinking as we were making a presentation. First of all, this idea of the success stories that you have in Latin America and also in Africa. I think one interesting issue is this thing that you raised about creating one-stop shop on the current tool. But more importantly, I think you mentioned about the country teams or country experts. To be nice, exactly what kind of country experts are you referring to, or what entities are you engaging with at country level? To be good to hear which ones. Second part was that I think to me, this is an area perhaps maybe where we need collaboration with yourselves, both Roberta and yourself, how we can collaborate and how you anticipate the kind of collaboration that we could have with yourselves. As you know, we have the Africa Continental Free Trade Area, and one of the things that we look to is how can those that are engaged into the business access the countries through various routes across border, what kind of roads are available and so forth. So it's quite an interesting piece of work that would be interested to work with you. So you don't have to answer that now. Perhaps maybe when we hear from others, you could combine the response to my questions and what others are going to be asking in a few minutes. So colleagues, the platform is open. We just had two exciting presentations, and I think they're very relevant to the work that we do on the continent, particularly CFTA. And other related pieces of work. I also see this quite related to the work around energy, for instance. Here I'm talking about electricity grids and things like very much related. How can all this apply? So I open the floor now for the two colleagues that we have, the able colleagues that are here to respond to questions. I know there's one question that came into the chat I saw was about training, I think. I think it was about training and so forth. So we'll come back to that. So any question, colleagues that are connected? Otherwise, maybe as we wait, I mean, you want to respond to what I raised, and Robert may also want to talk to those issues. Thank you.
Sure. So country teams, authorities, what I refer as. So sometimes the ultimate beneficiaries are the governments themselves, the road operators. Sometimes it's more an input to another project that is managed by the World Bank. So when I say country teams, is going to be the guys in charge of that project. It might, trickle down to authorities as well in raw format or in processed format. But it's up to we have a continuum in terms of who, but. Let me also relate to training. The idea is that we make it easy to use and easy, either to use it as an actual road maintenance. If you, we have a big project in Argentina with the road management authorities, in which case, we develop it's more ambition in terms of what you can do with the platform and how you use it, because you use it almost on a day-to-day to manage operations on the ground. But sometimes it's for much simpler things, like just to navigate or have macro statistics, in which case we adapt the level of fanciness. But again, we always train in terms of people and how to use and the platform is made for this. It's not just for this public initiative. It's done also for private operators that use it on a day-to-day, like for thousands of technicians. So it's made to be used by people. I guess that's what I'm trying to say. For collaboration, of course, there is a tendency. It's very hard to have an overview of what's going on. In our case, I started this initiative with Altea and people at the bank I knew, and it kind of blew up because we started burying our heads into the problem, because ultimately you see a lot of initiatives, but it's hard to know what's really 100% done, what's 50%, what's 10%. And at some point you need to just stop trying to figure out what everybody else is doing, and we said, okay, we're gonna try push it as far as we go, and I think and see what happens. And that's why we manage, I think, to also go as far, is because we kind of abstracted away from other initiatives. But now that we wake up, and that's also the objective of this kind of presentations, to realize that there are other initiatives, and we're obviously extremely happy to collaborate in any shape or form, obviously.
Thank you. Thank you, Roberta. Do you want to add? And perhaps maybe one question that you would also touch on, including it's about the cost. You were talking about low cost at country level that governments have to implement. How low is low on average?
So to give you a sense, we wanted that we started with the objective to have that you can have access to one to two blocks of analytics. So the basic blocks would be mapping of the network, pavement analysis, and the climate analysis around 50K. 50K was our target per country. I say around, it can be a bit above, it can be a bit. So I would say around 50, 60, 70, because it's the typical budget that we realize people have for a single shot.
Okay.
You know, it had to be for sure below 100K, and we're getting close to 50. Now, for all blocks, it might be a bit higher, but you see my point. Compared to doing this for pavement analysis itself, per kilometer, if you have to do it on the ground, is much more expensive. And again, here you have on top of that the climate analysis or the road safety. So that's also related to the platform. Moving to a continent-wide platform will bring this cost down even further, the marginal cost. Because every time we re-engage with a single country, you have project management. It takes time for the team to redo the audit of the region in terms of data, quality. You always have problems when you reapply. But say, if I like Congo and Burundi, if I do Congo, DRC, I might as well include the countries around. And for me, it's a fixed cost of analysis. So this is the kind of stuff that we're trying to achieve, is to find the extra funding to move to a global platform at the continent level to bring this cost down to below 50. Okay. And again, having access to everything at the same time, not just one analysis.
Okay, thank you. Roberto, do you want to add anything?
Yes, I just would like to add some particular aspect of our team that works on these kind of projects. We are related to work for road operators, as also the colleague, and also for the administration, regional administration of some areas, just to give them a tool for monitoring the road infrastructure, and also not static monitoring. Also using data from traffic, we can add some value added on the analysis of the road safety. The number of accidents we can represent on the network, the road accident, if we can get this information, of course, and of course using only the possibility to check, to monitor the road infrastructure using satellite imagery can have some cost if you can. Would like to use high definition images, but you can also use low definition images from some open data from some satellite constellation. Of course, depend on the money that you would like to spend, just to have more detailed information on infrastructure or less detailed information on infrastructure. Of course, we also implement other added value coming data concerning socioeconomic aspect or trade aspect concerning the logistics aspect. So we can also analyze. We have also analyzed in Africa some prediction on how the trade flow can increase in some areas, looking at the infrastructure, the road infrastructure that is present at now, and the road infrastructure that is going to be developed in the next future. So also see according to the capacity of the road, which could be the enhancement and the increase of the traffic trade flow along this road, or if you need to get more roads, more wide roads, or if it is going the good, I can see the good perspective for the future also to have the enough capacity for the trade that we are going to predict for the future. I'm not expert for the economic aspect because I'm a technician. I'm a more how can I say, more skilled about technical questions. So what I can see is that we can just with the actual technological improvement, we can achieve a lot of results using open data together with, of course, not open data, because for some aspect we are still linked to data that are not free, because the actual situations doesn't allow to get a lot of data. Not all the data are open, so this is the problem. If, for example, we would like to add the traffic information, we have to get this traffic information somewhere. It's not an open data that you can find easily. But I think that in the future also this information will be available also at a low level, or the cost of this information will decrease a lot if we have a lot of improvement in this technical aspect for the future. Just this.
No, thank you very much for that. That a very useful question. I mean, I am thinking as you were speaking also is the how we can actually bring this work to our colleagues that are working on the CFTA, because I think given the kind of platform they talk, the audience they talk to be good for them to actually understand the road infrastructure across the continent. So I'm wondering, my colleagues like Andre and Nika, I know that we are doing some piece of work around road corridors. I don't know, Andre and Nika, whether you want to come in here. There was another question somewhat, that talks about, although to me I think you've sort of responded when you talked about when you work to cover the DRC or indeed any countries that's nearby, you probably wants to bring, you want the cost analysis probably would go beyond just the country that you are working on, and that sort of reduces the price, the cost, so to speak. Yeah. So the question was that whether there are challenges when you do that, but I think that you've somewhat responded to that question. I see Robert, who is also working on the road corridors, and perhaps he wants to ask a question. Robert, please.
Yes, and I'm sorry I had another meeting. I had planned to be from the beginning, but just to say that Roberto, who just spoke, is working with us this year. So myself, my team, and Andre's team. So we have actually the ones who have engaged the Center for Transport and Logistics in University of Rome, where Roberto works. And the origin of this project actually answers your question or your suggestion to link with our colleagues in trade. I think this started when we did an analysis with University of Rome on the implications of the continental free trade area for demand for transport infrastructure and services. So basically, what does that mean for the investments that are required for infrastructure? Which are those road links that in their current state will not be able to accommodate the anticipated increase in trade volume. I think once we did that, then we started thinking, but we're having a challenge to know the state of infrastructure on our continent. The reason is that member states do not necessarily provide this information, even when we have focal points. And so we ask ourselves the question, how can we get this information on the status of roads with minimum requests from member states? And that's where we thought of the idea of using satellite imagery and artificial intelligence. Of course, we cannot do completely away with member states, but if we have some basic information from satellite image, then we can go to member states for verifications. And that's how we started with 3 corridors, the central corridor, the Dar es Salaam or the Northern Corridor and the LAPSET. So the whole idea is to hand over this tool, this web-based platform to LAPSET in August during a ministerial meeting. I think there are different layers of analysis. We want at the minimum to be able to give them a layer of their road network where they see the quality of their road. Is it paved? Is it unpaved? How wide it is? Where are the bridges, which can help them in their planning processes? Of course, the corridors want a lot more information. For instance, they want to know traffic flows towards the border post. There are also possibility of seeing the socioeconomic development. But these are additional layers that we think that even when we hand over this tool to the corridors and train them, then they by themselves will be able to add these additional layers because we know that they have their needs. They already have observatories, transport observatories, and they need to know traffic levels and so on. So, Oliver, I thought and provide some text of this.
No, I think that's
Roberto has presented.
Yeah, no, thank you so much, Robert. I think it really just adds on to the value for this. And I think beyond just the ministers that you're planning to present, perhaps this is something that we can actually bring at a very, very higher level during the Conference of Ministers next year, so that everyone across the continent is sort of aware of this kind of work, and that they can begin to demand perhaps for similar support, a similar initiative and tools that they can also begin to apply in their own country. So, but very useful. So thank you so much. I don't know if colleagues, there are others that have questions, but this is really interesting and stuff. Like I said, we can be applied in many scenarios. And I was also intrigued when I looked at the network for where we are, and then we see in other parts of Africa where we actually don't have much information. And this is why I'm thinking that maybe we could scale it up in terms of exposing this initiative to other countries, other ministers that are not necessarily part of the initiative at the moment. But thanks so much, Robert. Thanks for that. Yeah, and I mean, when you also read about, the presentation that was made by Dlamini for Latin America, you actually see success stories there, which could also be applied to Africa as well. So, Andre, do you want to say anything? Andre Yanika, you're part of the work that Roberto presented. Andre or Yanika?
No. It's okay, Director. I just channel a small question to Damien and Roberto in the chat box.
Yeah.
With the issue of collaborations, since we have two initiatives, I might say, running in parallel, and we know that regional integration, as the moderator has said, is critical, at least to the ECA policy work. How far, Damien, can we rather target the road corridor organization rather than individual country, so that to scale up the tool and the methodology you have developed and foster more cross-border synergy among country, and I'm raising here the mean of building collaboration between the two initiatives. How can we take this forward in that sense? Thank you.
Jamin, you want to take that on?
Sure. I mean, as I said, the question is not so technically, it's very feasible to cover the corridors that you have in mind, or to process all the countries that are critical to the corridor. So it's not a technical challenge. We could do it tomorrow. The question is more, organizing, making sure that it works for. I mean, I'm not an expert at what exactly you want to do in the context of your project, so we would need to tailor a bit the outputs. But yeah, I mean, we're very welcome. I mean, we're very happy to collaborate in the future. We have to probably sit down to think about something. But again, for me, even from my point of view, it's not. It would be the best way forward is to have something that is done more at the, again, regional level, continent level, whether you, but rather than, so we first designed it this way simply because it's easier to finance pilots in the context of a country team at the World Bank than suddenly people don't trust you straight to go for like continent-wide analysis, especially given the size of the project. So that's why we needed to show that we were doing some good work, and now we have like 10 countries in Latin America and 5 coming in Africa. So, but technologically speaking, it's very easy. Just maybe you mentioned 2 things. One was, I mean, there was a question on the accuracy. A question about the accuracy is increasing with the number of countries, and if you believe that there will be challenges when you extend to at the continent level. What we've seen, and I think it's a very good question, what we've seen is that technically, no. And the key is that the models obviously perform less if you are in, say, heavily when the vegetation is extremely dense. Because obviously, since we mostly use, I mean, in fact, almost only use free satellite imagery, the resolution is not as high. And so this is only where we could have problems in assessing the pavement condition. But by construction, almost when it's extremely dense, it's mainly in the countryside and it's not paved. So roughly, yes, when we scaled in very different countries, we realized that the performance was not moving that much, except in these portions of the country. And you were mentioning something about energy as well. I mean, I just wanted to mention that the same kind of approach could be used for other type of infrastructure.
Yeah.
We started with roads simply because it's the only thing that you can really see very well on free imagery. And even some aspects are pretty tricky to get, like the width of a road on free imagery starts being complicated. You need to increase a bit the resolution and the number of lanes, for instance. So, but again, we started really with this question about how far can you go at the country level with a minimum budget. And this is why we only relied on low resolution and free imagery and open data. But again, our specialty, I mean, their specialty at Altea is electricity mapping and monitoring. So of course they can tell you a lot more about how to assess the quality of grids, rail, but this is the kind of infrastructure where you would need to increase a bit the resolution, typically. So yeah, that's I think. Not sure if I answered your question, Oliver, but.
No, you did. Thank you very much. You did, and I think this is helpful. This is very helpful. I think, and I also agree with you that perhaps the approach was the best, that you start small, you demonstrate that this is useful before you scale it up to continental. But now you have 5 coming up countries in Africa and 10 in Latin America. You are beginning to show those as results. So it becomes easy to bring it at a regional level. It becomes very easy. So I would like to bring to a close this particular session, and really to thank you, Diamine and Roberto, for excellent presentations, but also I think gives us scope for collaboration. And that I think my colleagues, Robert, Andre, will sort of reach out to you to see how we can work with you, because for us this is large scope, and perhaps we may have to make a very deliberate presentation to our colleagues in the region, the one that deal with trade, because this is exciting and this is what they're looking for. Yeah. So thank you so much. I want to thank everyone that's been part of this conversation. And my colleague, the director for macro, I don't know whether she had an opportunity to listen to this. Should have actually benefited quite a lot, but she will listen to the recording of the presentation. So thank you, Diamine. Thank you, Roberto, and colleagues that have joined. I want to wish you the very best for the rest of the day. Have a great day. Bye-bye.
Thank you. Bye.
Bye. Thank you a lot.
Thank you.